Okay. All right. So for trig, so we've learned basic power rule for integration, and then we did the U sub, and then we did by integration by parts, and then we did some integration of trig integrals, which is not really a technique; it's more of a trig identity kind of stuff. And now we're doing trig substitution. So this is the basic integral by power rule, U sub by parts. This is like the fourth real technique called trig substitution. Okay, so there's three types of trig sub. So for integrals, involving the square root of some number a squared minus u squared, let u equal a sine theta, then the square root of a squared minus u squared is equal to a cosine theta, where theta is an element of negative pi over 2 to pi over 2. Okay. And then the triangle you would use would be this guy. Here's theta. Here's u. Here's a. And here is the square root of a squared minus u squared. So that's number one scenario. Number two. For integrals involving square root of a squared plus u squared, let u equal a tangent of theta. Then if we do that, the square root of a squared plus u squared is equal to a secant theta.
Let u equal a tan theta.
Yeah, this is a u right here. Make that better.
Thank you.
Where theta is an element of negative pi over 2 to pi over 2. And theta is equal to, the triangle would be u here, a, and the square root of a squared plus u squared. All right, so that's number two. Number three. For integrals involving the square root of u squared minus a squared, let u equal a secant of theta, then we would have, actually, no more space for this. Then we would have u squared minus a squared equal to this piecewise thing. A tangent if u is greater than a, and then theta would be an element of 0 to pi over 2, or negative a tangent of theta, if u is less than negative a, and theta would be an element of pi over 2 to pi. Triangle would look like this. Theta u square root of u squared minus a squared. Okay. All right. So we're going to use these as kind of like our formulas to guide us in the examples we're going to start.
A tangent theta and then a negative
Yeah.
a theta.
Yeah, it's negative a tan theta if u is less than negative a. Top one is a tangent theta if u is greater than
When negative a tan theta, when the theta is belong to negative pi over 2 and pi?
a. This right here?
Yes, negative pi over 2.
Yeah, this is a pi over 2 power
Pi over-
pi.
Okay.
Okay. Let's try an example and see which one would be helpful. Which of these three would be good? Okay, let's pick this guy. Okay. So first example, the integral of dx over x squared square root of 9 minus x squared. Okay. So this looks like scenario what? 1, 2, or 3?
1.
Yeah, it looks like a 1. Yeah. So we're gonna let so u will be equal to a sine theta, right? Let me think about this. So that's the approach we're going to use. Our variable is actually going to be what? X, right? X is equal to an RA. If we rewrite this question, that's lovely. If we rewrite it, we would have what? Dx over x squared square root of 3 squared minus x squared. So our x is equal to the a, 3 sine theta, right? Dx would be 3 cosine theta d theta. Do you agree with that so far? So I chose this. This is number 1 right here. It's just that our u is x, not u. So we're going to start preparing for the substitution. The other thing that you need to realize is that in the notes, we said that that square root part is equal to the a cosine, right? And so we said. So another note that we need is to say that 3 squared minus x squared is equal to 3 cosine theta, using that idea. So now I can sub everything, right? So dx will be replaced with 3 cosine theta d theta. X squared, well, I would square this, right? X squared would be 3 sine theta squared times 3 cosine theta. See how that's a lot easier to deal with compared to the original? So these are going to cancel, right? In a second. It'll be 9 sine squared theta times 3 cosine theta. So these are gone. So now what is the integral? It's d theta, 9 sine squared theta. That is the same as pulling out the ninth outside here and changing it to cosecant squared theta d theta. What is the integral of cosecant squared? Right, this is one of the ones you should know. This is going to be 1/9 times negative cotangent theta plus c. But just like when we did u sub, we need to go back to x. We're currently in theta, which is a problem. So we need to get back to x. But remember, x is equal to 3 sine theta, which means that implies that sine theta
We're backsilling, right?
is going to be, yeah, we're going to back sub now. We're going to be equal to x over 3. So using our triangle, the definition of sine theta is going to be opposite over hypotenuse, right? So use Pythagorean theorem to solve for the missing side. That'll be 3 squared minus x. Okay. So then, what is cotangent, right? Cotangent theta is going to be adjacent over opposite, so it would be this here. That should be a squared. So then replace that guy. That'll be negative 1/9 times the square root of 9 minus x squared over. So that'll be your answer. Oops, forgot to see. Minus 20 points. Okay. Now, do you see what's happening? There's a lot going on, right? So first thing we did, let's go over it again. So we look at this and say, okay, I can't integrate this, but I notice there's this pattern. So I can do a trig substitution. It's blurry for some reason. So if that's the trig sub, then I say, all right, well, define x equal to b 3 sine theta based on that idea. This right here will help you build a triangle later. Take the derivative because I need to sub dx and x with theta and d theta. So dx is replaced by 3 cosine 3 theta, right? X squared is replaced by 3 sine theta squared. And this right here, these two are from the definition or the property number 1. Okay, so all this right here, this little piece came from number 1. And then right here, I solve for sine to build a triangle. You can build that anytime you want. You can build it right at the beginning. That way you can finish it at the end. But anyway, so you do all the sub. These cosines cancel. We change that to cosecant. We know the integral of cosecant is negative cotangent. At that point, you just bring it back to x, and you're done. So it's just like u sub, you bring it back. It's just that you need to deal with your trig now. Is there any questions on any of the steps? Okay. And we'll do another one then, if you have no questions on this guy.
We'll just bring back what we bought from the very beginning, right? The 9 square root. And we back stuff from that, from right?
Yeah, that was from earlier, right? This one. And this is also technically 3 cosine. And x is 3 sine. So technically this would turn into cotangent, right? If you went back. All right, let's do another one. Okay. The x square root of 4 x squared plus 1. Is this scenario 1, 2, or 3?
Scenario 2, right?
Yeah, it looks like 2 to me. Okay, so 2 says what? Let's see, 2 is let u equal a tangent theta. And also they give you this information saying the square root a squared minus u squared is equal to a cosine theta. Right. So we don't have u, so we're going to change it all to x. So x is equal to, well, first let's rewrite this, right? So we can know what a is. Okay. All right. So, one second. All right. So our u, right? U is equal to 2x. Our a is equal to 1. So
Are we doing the first one or the second one?
the second, number 2. So I'm using 2 from the notes right here. Okay. And now, so we can say that u, which is 2x, right, is equal to a tangent, which is 1/10, tangent theta, which implies that tangent theta is equal to 2x, which means we can build the triangle right now and say that theta would be opposite over adjacent, which would be a triangle of sorry, that's a little weird. 4x squared plus 1. You can build a triangle anytime. That way you can be ready. Okay. Now, we kind of need x, not 2x, right? I'm going to move this piece somewhere else so it's neater. Use tangent theta equal to 2x to build triangle. Little note there. Here I need to solve for x and then take the derivative. So dx would be equal to, what is the derivative of tangent over 2? What's the derivative of tangent? I'm just doing K1, basic K1 stuff. It'd be secant squared, right? You guys remember? Derivative of tangent? Okay. We got x, we got dx. We also got to rewrite this guy here. So we have the square root of 1 minus 4x squared equal to a cosine, just cosine theta. So this whole thing will be replaced by cosine. Okay. Now, hold on a second. Let me check something. Sorry, yeah, it's supposed to be a secant. My bad. Yeah, something. I need to figure that looked weird. This should be a secant right here. Nothing else changes because I was only about to use it right now. This right here. This secant. Okay. All right, so now we do the sub. Got everything we need. We got this part equal to secant. We got dx equal to this d theta. Right? We got x. We're going to replace anything that we need to replace. So the top part will have 1/2 secant squared theta d theta. The bottom will be secant theta, and that's it. So now notice how easy this integral is, right? You pull out the half in front. Secant squared divided by secant, that's just secant. Right? Integral of secant, that's going to be 1/2 ln of secant theta plus tangent theta plus c. But we're not done yet. We got to use the triangle to get back to x. So secant, write down the definitions in case you guys forgot. Secant is technically what, 1 over cosine. So that would be hypotenuse over adjacent. Tangent is opposite over adjacent. Right? So this would be hypotenuse over adjacent. So that would be 4x squared plus 1 over adjacent plus opposites over adjacent. That would be 2x over 1. There we go. We back sub to x. Any questions on any of these steps?
Professor, I have a question. So is any of those problems from the ones that we learned in 8.1 up to 8.4, is there a rule that can, if you didn't remember the rule for 8.4, that you can use the rule for 8.3 or another rule that can solve the problem? Because maybe it will be very hard to remember all the rules from 8.1 to 8.4 is a lot. Is there a magic rule or some way to help if we didn't remember?
No, I mean, sometimes you have to use this technique. It's just like kind of like back in derivatives, right? Like sometimes you have to do
Right.
chain rule.
Yeah.
You have to do quotient or product or whatever. There's no way around the trig sub. If that's the only way, that's the only way. Sometimes you can do a different way, sometimes. But sometimes trig sub is the easiest way or
Okay.
the only way.
Got you.
Yeah, looking at this original question, I don't see any way, and I don't see any other way to do this. There is no U sub, there is no by parts. There's no technique later on. The only way is trig on this one.
Okay. I was just asking.
No, I understand. Trig sub takes some getting used to. We'll keep doing them. Just gotta stay organized. So the first step is identifying, okay, which one do I do? 1, 2, or 3? Once you know, you start setting it up like this, right? So I see that there's a sum. So I set it up. And all right, well, it says I should let 2x equal to a tangent. So 2x equals a tan. Solve for x, and then I can find dx. Because I'm going to replace dx and everything I can, right, to get to theta, d theta. Just remember that tangent equal to 2x. Do you guys remember your pre-cal? Because this is when all the pre-cal is coming back, right? So don't forget. And so remember SOHCAHTOA, right? The sine theta is opposite over hypotenuse. Cosine theta was adjacent over hypotenuse. Tangent theta is opposite over adjacent. So you need to remember all these ideas. So that's why I was able to find these pieces. So you build the triangle using the definition. Tangent is opposite over adjacent, so opposite to an angle. So 2x over 1 technically, it's always there. So you do opposites over adjacent. That's the definition of tangent. You do Pythagorean theorem to solve for the hypotenuse, right? Once you have all three, you can find sine, cosine, tangent, secant, cosecant, cotangent. You can find all of them, but you only needed these two to get back to x, right? Once you do this, you're done. And that came from the triangle. Okay. Let's do another one. Okay. Okay. So this is dx over x squared plus 1 to the 3 halves, which can be rewritten, right, as dx over the square root of x squared plus 1 cubed. So which one is it? Rule 1, 2, or 3? Which trig sub are we doing?
either 2 or 3.
Let's see. Number 2 has the plus, right? So it's got to be this one. So I'm going to let u equal a10 to start. And then I'm going to remember this fact and start filling in the pieces that I need, right? So let u equal a tangent theta, which implies that x is equal to 1 tangent theta, right? Because this is just a 1. Sorry, not on the screen there. Then they also say that secant, a secant is equal to this. So this is that a secant theta is equal to the square root of a squared plus u squared. Which means, right, change that back to our x stuff in this specific problem. Our a is 1, our u is x. So that would be 1 secant. Let me write that better. This would be 1 secant theta is equal to the square root of 1 plus x squared. Okay. Now I have pretty much everything I need, right? Except, so I'm going to rewrite it so it looks prettier. So this is just from the notes, right? So now I know that x is equal to tangent theta dx. What's the derivative of tangent? Should be secant squared theta d theta, right? Okay.
Yes.
And then we have this fact over here. So we're going to use secant theta is equal to this. So this is all the stuff I'm going to use that I got from those notes. Now you can build the triangle anytime you want, as soon as you have the x equal to something, right? So since tangent is equal to x, which is equal to opposite over adjacent over 1, right? Opposite, adjacent. So the hypotenuse would be x squared plus 1 squared. All right. So now I have everything I need to start. You guys have any questions on where all this stuff came from?
X over 1 equal what?
So you understand x is equal to tangent, right?
Right.
So since tangent is equal to x, we can always put over 1. There's always a 1 down there.
Right.
Now I go back to the definition. What is the definition of tangent when it comes to right triangles?
Yeah, opposite over adjacent. Got you.
So opposite, adjacent. Then solve for hypotenuse, right? So
Got you.
back to this stuff, right? So x squared plus 1 squared is c squared. So c is the square root of 1 plus x squared. That's where that came from. Now we can do the sub. Now we're ready. So the integral of dx over x squared plus 1 dx is now this. So I'm going to replace it with secant squared theta d theta. So sub it. And this nonsense down here is equal to secant, right? Yeah, here. So that'll be secant theta cubed, right? Do you see how we got here?
Yes.
Yes.
So then that will be d theta over secant, right?
Yes.
Which will be cosine theta d theta, which is sine. That was an easy integral, right? Once you sub, this is way better than trying to figure this thing out. So trig sub it will help you. You just gotta get used to it. Once we get there, we just gotta get back to x because we're not doing sine theta stuff. So sine is equal to, remember, the definition of sine is opposite over the hypotenuse. So that would be x over this. That makes sense?
Yep.
Yes.
Alrighty. Let me check the schedule. I don't know where we're supposed to be. All right, so we square first. Rearrange it so it looks like rule number 1. That's what we did. Then substitute u for what's in here, x minus 1 equal to a sine. A is 1. Okay, I'll make a note over here that u is x minus 1 and that the a was 1. So that's where this came from. I solved for x, took a derivative, and since I had sine to begin with, I can use that to build the triangle, x minus 1 over 1. So if theta is here, opposite over hypotenuse, right? I should be able to find the missing part, which will be what? So b will equal the square root of, oh yeah, 1 minus. There we go. Okay, I got my triangle, got my subs ready. Got this from the notes, so I can start the integral, the trig substitution. All right, so we're right here, x squared dx over square root of 1 minus x minus 1 squared, which is x is sine plus 1, so that'll be sine theta plus 1 squared. That's what x is, right? Dx is equal to cosine theta d theta. Okay. And then the bottom is equal to cosine. All right. So those cosines will cancel, leaving me with the integral of this square. So that'll be sine squared theta plus 2 sine theta plus 1 d theta. Integrate this nonsense. I would have to do a power reducing on the sine squared. That would be what? 1 minus cosine 2 theta over 2, right? For the first term. The next one will be 2 sine theta d theta plus d theta. Okay. So that will be 1/2 theta minus sine 2 theta over 4 minus 2 cosine theta plus theta. I almost fit it in there. Plus C. Can you guys read that? I kind of jammed it in there.
Kind of barely read it. There we go. You move it
So
to the right a little bit, to the left.
so I integrated this guy right here and got these first two terms. And then I integrated the middle one, which is this one, and got 2 cosine, negative 2 cosine. Integrated theta and got a theta. And then of course plus C.
That's minus sine 2 theta over 4.
Yeah. So the final answer, well, final trig answer will be, let me write it again. This will be half theta plus theta, that'll be 3/2 theta. Minus sine 2 theta over 4 minus 2 cosine theta plus theta plus C. Yeah, I think I need another page.
Is that cosine or sine? Yeah, cosine.
This cosine right here,
Cosine theta.
negative. Yeah, this is a hard one, but we're doing all right so far. But before we go any further, are there any questions on page 1? Do you see the setup and do you see the integration? And the trig
On the bottom for the 3/2 theta, is that because you added the half theta and the other theta?
Yes, yes.
Okay.
Is there anything at the beginning that didn't make sense or in the middle? It doesn't matter, guys. Let me know.
I was wondering, how'd you get the negative sine 2 theta over 4? I'm trying to figure that out right now.
Oh, the integral of negative cosine 2 theta over 2 is going to be a u sub, which will eventually get you a sine 2 theta over 4. I skipped that, and I skipped the integral to save space, but integrating this piece right there. Cosine 2 theta over 2 will be this. Cosine, the integral of 1/2. So you separate this fraction, right? 1/2 minus cosine 2 theta over 2, and you get these two answers. Okay, you see what I'm saying? Or no?
Yeah, I think, yeah, I think.
Yeah, just remember, integrate 1/2 gives you 1/2 theta. Integral this guy gives you this. But if you're wondering like how do you find it, you have to do a u sub or use that shortcut I gave you last time.
Then we plug back in, right?
Yeah, we're not done yet. We need to come back and sub everything. So
Theta.
I'm gonna have to maybe rewrite some of this on the next page because I'm not gonna remember all that. So right now we have 3/2 theta, right? Minus sine 2 theta, is that what it was?
Yeah, sine 2 theta over 4.
Okay, next one. There's 2 cosine theta.
Cosine theta.
Let's see.
plus
Oops,
A.
I wrote an extra theta there. My bad. On the first page, I already combined that theta. It shouldn't be another one.
It's just plus C.
Yeah, just put a C. Now I need a triangle because I can't do anything without that. I can't resub without a triangle. So we had x minus 1 right here. We had 1 up here. And we had the square root of 1 minus x minus 1 squared. Okay. We also had the idea. What was it? Oh yeah, we said sine theta is equal to x minus 1, right? Which means that theta is equal to sine inverse of x minus 1. So I have to do sine inverse of both sides to solve for theta. That's the only way I can get this guy. See what I'm saying? Also,
Yeah.
we need the formula. What is sine 2 theta? Do you guys remember from pre-con? What's the
Yeah.
double angle formula?
Double angle is it's for sine 2 theta. It's 2 sine theta cosine theta.
2 sine theta cosine theta. So we're going to need that because the triangle is only for regular trig functions. I don't have sine 2 theta in here, right? This is regular theta. So I'm going to rewrite that as minus 2 sine theta cosine theta minus 2 cosine theta plus c. Okay. So all your pre-cal is coming back, right? To Hantu. I need more space. Okay. So 3/2 times sine inverse of x minus 1, that's the first piece, minus 2, oops, I've got the 4 down there. So that'll be just over 2 now, right? So sine is equal to x minus 1 times cosine, which is this, over 2, right? Minus 2 cosine, which is minus 2 this thing. Let's see. Now let's pray a little bit and hope that's correct. Let's check. All right. Oh, it looks like they combined stuff. Hold up. Yeah, 1/2. Close, but there's something missing here. Unless they did some algebra magic. Let me see. They might have. Oh, yeah, they did. Bunch of douchebags. Okay. The only thing I don't have is they have 1 minus x in here. I don't think that matters though. Let me double check. Earlier we said that sine Yeah, it doesn't matter. It's just the way I defined it. Okay. Let's keep going. They did some algebra to make it look different. I don't think this is wrong though. So I'm going to factor square root of 1 minus x minus 1 squared from both of these. That would leave me with negative x plus 1 over 2 minus 2 plus 3 halves times sine inverse of x minus 1 plus c. So that would give me what? Combine this garbage. That would give me what? Combine these numbers, 4 over 2. So that would be negative x plus 1 plus minus 3 over 2. So I'll put out the half. I'll do that on the next step. I'm just trying to get the answer they have because they did extra algebra that was not necessary. This was good enough, but you'll see what I'm saying. Factor that negative in half, and you get this. And that's it. I guess I don't need all those brackets. Just to make it a little bit prettier, that would be 1/2 x plus 3 times the square root of 1 minus x 1 squared plus 3 halves sine inverse x minus 1. That's as pretty as it's going to get, guys. But again, this is the last question in that homework, so this is one of the harder ones. So don't get discouraged, yeah?
You got 3x. I was coming up with the natural log. That's why I was like, man.
You got natural log?
Mm-hmm. But
No, shouldn't be any logs in this one. Is there any steps that don't make sense? I mean, we were done here, just FYI. This is the answer. But I looked at their answer on the homework, and they went all the way to here. Theirs is slightly different, but I think this is good enough for me.
so you got 3 halves arc sine x minus 1 plus c.
They have 1 minus x with a negative 3 halves, but that's the same thing. Yeah, this is good.
I came up with that answer one time. I don't know.
At least we did the hardest one, right?
Yeah, it was real difficult with that one.
Yeah. Yeah, the last two I think require completing the square. This one was just a weird square, and then it had a bunch of stuff going on. So anyway, does anyone have any other questions they want to work on, or we're stuck on?
So Goodness. Wow. All right. Take a look at it real carefully. Go through it again. See
Yeah,
where
it's a tough one.
I made my mistake based on
Okay.
what you show me.
That's fine.
Because you had on the triangle, you had the square root on the
Yeah, wait till you square with this part here.
I had it on the opposite. I don't know
Over
why.
here.
Yeah, I had it over there.
Wait, did you put your theta here though?
No, my theta was there, yeah.
Yeah, if the theta is here, then it's supposed to be this way. But if you moved your theta this way, then yeah, maybe or up here or something.
No, my theta was there, just
Okay.
have it.
Actually, this is the right angle, so you can't move it there. But you could put it up here.
Yeah, I had everything 180 out and set up incorrectly. So I had 1 over cosine.
Yeah, if the triangle's messed up, then when you the whole resub would be wrong. So maybe start or I guess you erase everything after the sub and check before that
Okay.
if it's good. So like everything up to here, everything after this, I would erase if you messed up this triangle.
Okay. Yeah, I'm gonna have to look at that. Thank you.
Yeah, well,
That was one, and then the one before was the last two are real tough.
well I'm glad you asked because you got more practice.
Professor,
Mm-hmm.
if we after we done with the class today, can you do just one problem, even an easy one for tabular method?
Oh yeah, that's right. Let me go look for one. So tabular you can use tabular with any by parts question.
With anyone?
Any question that you do by parts, integration by parts.
Yes. Okay.
So you can do tabular on any of those. So let me pick one. Okay. Yeah, I just picked number 5 from the homework. We have 3x over e to the 4x dx. So we need to rewrite this as 3x e to the negative 4x dx. And then we need to choose what is u, what is dv. Right, so integration by parts is v u times dv is equal to u times v minus the integral of v du. So u will be 3x because I want to take derivatives of that. dv will be the exponential because I have to choose that. Integration of this will be negative 1/4 e to the negative 4x. Du would be 3 dx, but now if we use this, that would be with the other method, right? So let's look at the tabular rules. Where did I put that from? One second. All right, here we go. So tabular method. So this is how you would set up by regular by parts, right? But let's use the other method. All right, so remember, it starts with a plus, then goes to minus, Goes to plus, goes to minus, does that forever. Those are the alternating signs. And then we put the u and its derivatives. So u would be 3x derivative. I don't need this one. It's too much. Integral. So this would be dv and integral. It's integrals, I guess. So dv is e to negative 4x. First antiderivative or integration would be negative 1/4 e to the negative 4x. Another one would be positive 16 e to negative 4x. And then the formula goes like this, right? Goes this way and then down this way. And then the next one this way and then down this way. And then that's it, because if I go again, it's 0 and there's no more terms. So the answer for 3x e to negative 4x dx will equal plus 3x times negative 1/4 e to negative 4x minus 3 times that bottom one 1/16 e to negative 4x plus c. So to make it pretty, this would be negative 3x over 4 e to negative 4x minus 3/16 e to negative 4x plus c.
Okay, the question here, not in the last line, in the line before the last line, why you put minus in between? You said the first part minus the second part. How you get the minus in the middle?
Oh, it's from here.
Okay, so the first part always minus the second part. It's always like this, or from
I don't change the sign of the first part, but there was already a negative there, right? So
Okay.
that became negative. But the second part, I have to add an extra negative. So negative times whatever I get here.
Ah, got you. And by the on the signs as on the left, the plus minus plus, it always plus minus plus, or the
Yeah.
first sign start with the sign of the original equation, like the 3x is positive, so we started with the positive. If it's negative, we start with the negative, or no, it's always
No,
positive.
it's this is always plus minus plus minus plus.
Okay.
But if this is negative though, you put a plus on the negative, which stays
Right, it's negative, right? But the other one will be negative, and if it will be negative, but if the other term is negative is positive, right?
Yes, right. That's correct.
Thank you very much.
Sure. You guys have any more questions?
That term that you came up with, Mr. Gonzalez, it doesn't accept it.
Doesn't like it?
No.
Here, let me give you another one then. Hold on.
I
I'm pretty sure it's right. They just don't like how I did it, probably. Hold on. Let me get it for you.
Bet you it's over e to the 4x.
Oh, you're talking about, no, I think, which question did you mean, Tomas? Did you mean the last one we did or this one?
the last one we did.
Okay, all right,
Yeah.
let me check.
Yeah.
Okay.
It's all right. I'll get back to
I'll
you.
get it to you. Hold on a second. No big deal. The question was originally x squared over square root, right?
Yeah, x squared over square root 2x minus x squared dx.
Alrighty. Let me see if I can just, if it lets me paste it in here, that'd be great.
I just don't
One
want
moment.
anybody else's time. You know, whoever wants to ask another question.
My computer's freezing. 1 second. Stupid tool. Which one is it? Okay, so this is problem 10 from 8.4, right? So it was.
Yes, sir. It's 8.4034.
So here is problem 10. This is the answer the way they wrote it. But it should be this. It's the same crap we did, so I don't know why they don't accept it, but whatever. Use this one.
I think they're
Did you get it?
no, it's frozen. It's not showing up.
It's in the chat box. Can you download it or no?
Oh, okay.
It's just a picture file.
Okay. Yeah, I got it. Why do they want the C in the front?
It doesn't matter. You can put it at the end. But the only difference I see is they wrote sine inverse 1 minus x and made it negative. I think that should be equivalent to what I have. So I don't know why they're being weird. But just use that one. It's fine.
Okay.
If anyone else wants to use that for number 10, that's totally cool. You should probably all have the same question, I think. Anyone else have any other questions from previous homework or the current one?
Still took it wrong. That must have messed up. Oh man, I screwed it all up. Okay.
If you guys have no more questions, we can stop here then. I'll do partial fractions next time. You guys, before you let you go, do you remember partial fractions from either college algebra or pre-cal?
Yeah, I was working on it earlier.
I still have my notebook with all the notes in it.
I had to go back. I had to go look for some notes and all that.
Okay. Yeah, I suggest reviewing partial fractions before we start. I mean, I'm going to go over it anyway, but it'll help for you to grasp it faster. If you practice partial fractions beforehand, it'll make more sense. Because basically, this next technique of integration is just regular integrals taking advantage of the partial fraction technique. So it's more of an algebra technique that they use. So when you first learn it, there's not very many applications. So you don't actually use it until Cal 2, and it's actually pretty useful. So look it over again, and if you can, and if not, we'll talk about it Wednesday.
Yeah. I on question 10, I blotched it, so it's all right, man.
You got my answer, right?
I got your answer, but when I typed it in, the last part for some reason didn't take it when I hit enter, and I had typed it in there, but it blotched it out. So I don't know. I'll just take it as that question just ate me up. So
No, that's fine, man.
I'll just
We tried.
Professor, a question not related to the problems. because I wonder is calculus 3 is harder or calculus 2? Because calculus 2 for me is like a wild beast. I feel like I have to go to the elementary school and look for the rules from the elementary school to apply it now. I'm dying.
No, I think that's normal. You should. Cal 2 can feel. Most people suffer in Cal 2 because they have to remember all those basics and it's rusty.
Right.
So it's hard because you need to remember your pre-calc, you remember your algebra, you remember your derivatives, and if any of those are missing or rusty, then Cal 2 becomes harder and harder. So you have to review all that stuff in the background.
Yeah, and so as I told you, any extra credit is appreciated. Anything you can do for us is appreciated to just get C. Put my heads up the water, just get C. I don't want to die.
Did you do the partial credit? The extra credit is due tonight.
Yeah, I did it. I did it at the same day.
All right, good. That's good. So if you haven't done it, please do it. It's due tonight.
Thank you so much. I'm just kidding with you.
But yeah, if I put some other stuff, I'll let you know. But Cal 3, basically, they're going to assume you remember integration and derivatives, and they're going to go to 3 dimensions.
Okay, got it. Thank you.
So don't forget Cal 2.
The 3 dimension of what we are living right now, so it's in 3 dimensions.
Yeah, because right now we're in, this is like what? This is 1-dimensional problem right now.
Okay, thank you. You make me feel comfortable.
Yeah, so Cal 3 is tough, but it's very important, useful in physics and engineering and applied stuff. It's pretty neat, but
Right.
you need to make sure you get the basics, derivatives and integrals before Cal 3.
Yeah, I'm going all the way back to old notes and pulled out old college books so I can see, so I can remember this stuff. It's been a long time.
Yeah, it's I mean that's how I felt when I took Cal 2. It was lots of suffering and confusion. Just a lot of, you just gotta keep practicing. There's the only thing I can say is I was practicing every single day, so it made sense.
That's what I'm trying to do. That's why I was asking this one question. This last one, it was frustrating me. I worked it out so many different ways, and then I was just getting frustrated with it. But thanks for giving me the answer. At least I botched it putting in the answer, but I appreciate it.
Yeah, we both tried, I guess. But yeah, are you all? Is everybody engineer here or math major? I forget.
Yeah, I'm going to be a computer engineer if I pass this class.
Mechanical engineer here.
So you're all gonna need a EA1, right?
Yeah.
Or which is basically differential equations.
Yeah. Yep.
So yeah, so then when you get to that class, they assume you remember all Cal 2, all the integral techniques that we're doing right now. So like when you get to Cal 1, you know how they assume you remember algebra. When you get to that one, they assume you're really good at integration.
Okay.
So don't forget by parts, don't forget power rule, don't forget trig sub, because it's going to come up a lot in that class. I would recommend taking that right after Cal 2 if you can, before you forget.
Okay. Yeah, I gotta first get to this one, then I gotta take that one next.
Yeah.
I have two more classes I have to take. I have to take differential equation, and I have to take discrete math.
What's your major, Tomas?
I'm majoring in computer science, but
Okay.
There's discrete computer science, which is discrete math. I don't know why they just didn't tell me to take discrete math before I do that class. I did horrible in it when I took it. A lot of students told me to take discrete math before taking that course. It's not a prerequisite, but everybody highly recommends to take it. So I'm gonna go back and.
Yeah, no, I think we're starting to offer that soon.
Professor, did you give a differential equation? Do you give the class for differential equation?
I used to, but nobody ever signs up, so it always gets canceled. So
Okay.
if people sign up,
Him
then
and
that'd be
he can
great.
abuse you.
Do you do the one with the linear base?
Well, EA1 is the one that has differential equation and a little bit of linear. Differential is just differential.
Okay.
Like if you're, I don't know, if you're going to UTSA, I know they'll replace EA1 if you take differential and linear.
What is the EA1?
The EA1 is just it's engineering, applied engineering, engineering analysis. That's what they call it.
Okay.
At UTSA, and I think they might have a different name at other schools. I forget, but basically it's just a lot of differential.
Is it required for architecture? Architecture?
Architect? No, I don't think so. I don't think they need EA or differential.
Think about going into that. Switching my major, computer science.
I know architect does a lot of like projects and building models and stuff.
I'm not too crazy about the computer science program. Okay.
Computer science? Yeah, I mean, if you like programming, it's a good field.
Because that's what I'm studying programming right now. But, it's a programming engineer, but I don't know. Just I feel like I'm not learning anything in that field. The courses I've taken, it's just I feel like I'm learning how to write these languages, but I couldn't. I feel that I can't apply them. That's about it.
Yeah, I mean, programming is just it's kind of like math. You just gotta keep practicing until you get good at it. But as soon as you stop programming, you start to forget.
I don't remember. I wanted to talk to you about the engineering